Good morning, GLA Middle School. It's Mr. Manta here. Today's date is Tuesday, April 28th, 2020. And you know what, guys? I'm really starting to miss, one of the things I really missed from being in class was my morning and afternoon greetings with you all when I would say, "Good morning, Purdue," and you'd say, "Good morning, Mr. Manta," right back to me. I miss it so much. So you know what? How about for today, just for fun, if you're hearing this, go ahead and say "Good morning, Mr. Manta," or "Good afternoon, Mr. Manta," in the comments under today's video lesson. And if you do it, I will give you a +2. And if you can figure out how to do it in a language other than English, maybe I'll give you a +5, which would be very extra special. Anyway, today's date is Tuesday, April 28th. This is going to be lesson 10 of our chemistry unit, and we are going to start reviewing for our quiz, which we are having tomorrow, ladies and gents. First things we got is a do now, reviewing what we learned yesterday in our lesson all about chemical changes. These are your 5 questions. Go ahead and pause the video, complete these 5 questions about yesterday's lesson now. Alright, I'm now assuming you've unpaused, you've answered these 5 questions in your notebooks, because here are the answers. Number 1, a chemical change happens when the particles that make up 2 or more substances are rearranged to make a new substance. That's what makes something a chemical change. You create a new substance from old stuff. 2, one sign that a chemical change has happened is if an object changes some of its properties, such as color and texture. Yesterday we talked about baking a cake or burning a match as examples of chemical changes. The cake batter changes its properties from before and after you bake it. It goes from a liquid to a solid at room temperature. It changes its color, it creates a smell. These are all different properties that change that tell you that a chemical change happened. Number 3, true or false, when you mix together the ingredients for a cake, you're making a chemical change. That is false. At that point, when you're mixing together ingredients, all you're doing is creating a mixture. No chemical change has happened yet, and you could undo it. You could theoretically separate out the ingredients again, if you were smart about it. Number 4, true or false, when you bake a cake, you're making a chemical change. That is true. It is in the baking of the cake that a chemical change happens. Mixing, no chemical change. Baking, yes, chemical change. And number 5, which of the following are signs that a chemical change has occurred? Well, of all the different stuff that I listed here, it is only these 4 that are signs that a chemical change have occurred. It releases gases, the change can't be undone, it releases light, and it gives off or takes in heat. Those aren't all of the signs of a chemical change. We talked about 6 of them yesterday, but those are 4 of them that are going to be pretty common. All these other things are not indications that a chemical change has happened. Just because 2 liquids are mixed together doesn't mean you have a chemical change. Just because something is dissolved does not mean you have a chemical change. Melting is also not an example of a chemical change. And I would certainly hope that you don't go forward in life trying to identify chemical changes just on the basis of, well, Mr. Manta says this is a chemical change, and that's how I know. Unfortunately, I'm not always going to be there to tell you guys whether something was a chemical change or not. And so you have to know all the different signs yourself so you can identify them. All right, moving on from there. Now, I mentioned this yesterday, but a lot of you guys got it wrong on the exit ticket. We are having a quiz tomorrow, ladies and gentlemen. It is tomorrow. It is not next week. It is tomorrow. And I would just give an extra special recommendation that throughout today's review lesson, you be taking notes, because quiz, I'll just tell you right now, it's going to be an open note quiz. That means you can go back through your notes and you have them help you answer any questions that you're confused on. But please do not go back and rewatch the videos. I mean, that would take you all day to try to rewatch the videos for all the questions tomorrow. It's probably going to be a pretty short, pretty simple multiple choice quiz, recapping the stuff we've talked about so far. Properties, melting, boiling, conductivity, solutions, all that kind of stuff. Matter and properties and all that. Now, yesterday, I asked you guys for the first classwork question. We kind of went through all the stuff we've covered in the unit so far, and I asked you guys what are some things you're still a little bit confused on. And I looked through everybody's answers, and there were 2 main things that I saw most people saying. Number 1 was this idea of conductivity. They wanted to hear more about conductivity. That was when I took my little circuit board out and I showed you guys that if I connected the circuit in the right way, I could make a fan spin around. We're going to talk a little bit more about that today. And number 2 was all these words about solutions, solvents, solutes, and all that kind of stuff. So we're going to review that as well today. Focus on these 2 things. First of all, talking about conductivity. I would recommend writing these things down in your notebook. Some objects are conductive, and some are not conductive. Conductivity is a property. this is the main thing that you need to know about conductivity, is that it's a property like reflectivity or color or magnetism or all those other properties we've talked about. And some objects have the property and they're conductive, and some objects don't and they are not conductive. Or you could say that they are more or less conductive, because yeah, some things are kind of in between. The second thing you should know is that if an object is conductive, that means that electricity or heat can travel through it. Generally, if something is conductive, it's conductive both for electricity and for heat. But what conductive means is that those things can travel through it. Now, what does it mean for electricity to travel through something or heat to travel through something? Well, I've got some diagrams that should hopefully make this a little bit clear. What you're looking at here is kind of like a drawing version of that circuit board that I was showing you. And the basic way that we need to know that electricity works, and we're not talking a ton about electricity right now, but the basic idea behind electricity is that when you have a source of electricity, like a battery, the way a battery works is you connect it to a whole bunch of wires, and the electricity in the battery wants to go in a full circle. It wants to start at one end, this positive end over here, and travel all the way through and come back to the negative end. And if the electricity can travel in a full circle, it's going to power up anything that's along its path, such as this light bulb right here. Right now, the electricity in the battery can't travel in the full circle because if it comes through this wire here, it gets to this spot right here where there's a gap, and it can't pass through this empty gap of empty space so that it can keep on going over here. That means that it can't perform this full circle, and if you're looking at this light bulb right here, it is not lit up. It's just dark because the electricity is not traveling through the full circuit. Now, if we took an object that was conductive, what that means is that we could put that... here you go, if you want something to write down in your notes. Electricity needs to travel in a circle in order to power things. If we took an object that was conductive, what that would mean is that we could take it like a spoon, and a spoon is an example of, it's an object that I showed you in the last lesson, is conductive because it's made of metal, that we could put it inside of this gap right here, and it would kind of form a bridge for the electricity to travel through. So now, in this diagram, whereas before we had this gap and the electricity couldn't travel in the full circuit because it would be stopped, now in this diagram, the spoon is bridging that gap. And the electricity can travel along the wire and travel through the spoon and then keep traveling along the wire back to the other end of the battery, and it will light up the light bulb in the process as it's doing so. You'll see the light bulb lit up because this spoon is an object that is conductive and electricity can travel through it to complete the circle. If we took an object that was, and just if you want something to write down in your notes, some objects are conductive, like this spoon. That means electricity can travel through them. But if we took an object that was not conductive, and we tried to kind of use it as a bridge to fill that gap in the same way, maybe like a popsicle stick, then the light bulb would still not turn on because electricity can't travel through that. So the electricity here is still trying to come out through the battery, through the wire, and then it gets stopped right here. Even though there's a popsicle stick here, it's not a conductive object, and so the electricity can't travel through there. It gets stopped, and your light bulb stays off. Some objects are not conductive. That means electricity can't travel through them. So you can't use your popsicle stick to complete your circuit. Now, that's about electricity, but we said you can also conduct heat. And here's what that would really mean. So if I took my popsicle stick again, and I had something that was really hot, a source of heat, and I could put a source of heat under one end of it, what you would find is that, just like electricity, some objects can and some objects can't conduct heat. So if I took a little flame or something that was hot, and I tried to heat up this left end of the popsicle stick, and I left it there for a little while, but I managed not to catch it on fire, eventually what you would see is that that side of the popsicle stick would start getting hotter and hotter and hotter. However, because a popsicle stick, this wooden thing, is not conductive, the other side of the popsicle stick would still stay cool. It would not heat up. All the heat would just stay down at this end, and it would not travel down to this end and make the other side hot as well. It would just stay here. That's because a popsicle stick can't conduct heat. If you heat up one end, the other end will still stay cool, like you're seeing right here. That's different from if I try to do this same exercise and I use the spoon instead. If I put one end of a spoon over a fire or a source of heat like this, then yes, then that end would first start to heat up, but if I waited just a little bit of time and I let that continue, eventually the heat would spread to the entire object. And even this side of the spoon over here would start to get super, super red hot. And if I tried to take my finger and touch this end of the spoon, it would burn me. It'd be really hot because the heat traveled from this end over to this end. And that is because this spoon does conduct heat. If you try to heat up just one end, the whole thing will get hot. That's because it's made of metal, and metal is conductive for heat. So, just to review, we looked at two objects just now. We saw that a spoon is conductive for electricity, and it is conductive for heat. That means that electricity and heat can travel through one end to the other. Compared to that, we also looked at a popsicle stick, and we learned that that popsicle stick is not conductive for electricity, and it is not conductive for heat. So if I power some electricity or put some heat at this end, nothing will happen at this end because that stuff can't travel through it. It just gets blocked. Alright, keeping that in mind, I want you to go ahead and answer classwork question 1 right now on the form or in your notebooks, and then later put it in the form. Here it is. Which material do you think is more conductive, metal or wood? And how do you know, based on what we were looking at just now? Go ahead and pause the video and answer classwork question 1 now. I am now assuming that you have completed that question. You are unpausing the video, and we are moving forward. The other thing that some people said that they wanted some review on was all the vocabulary that had to do with solutions, solutes and solvents and all that kind of stuff. So that's what we're going to do. Just to refresh your memory, a solution is any time that you take some kind of substance like Kool-Aid powder or salt or sugar or something like that, and you mix it into a liquid and create a mixture where the two substances are perfectly spread out. So all this Kool-Aid or whatever, maybe it's lemonade powder that someone's pouring into this glass, it doesn't stay just clumped up at the bottom. It spreads out perfectly throughout all of the water. So the particles are perfectly spread out all throughout the water, and it looks almost, you can't even see the particles anymore because they're dissolved. Now, when we're doing this, anytime that you dissolve a substance in another, there's three components here. First of all, you have your solute. That's the thing that gets dissolved. So if you're making Kool-Aid, the actual Kool-Aid powder inside the packets is your solute. If the second part is always going to be the solvent, that's like the bigger part, the liquid usually. That's the thing that the solute's being dissolved into. And then lastly, you have your solution. And in this case, that would be the Kool-Aid, which is the actual combination, the mixture of those two things. The solute and the solvent together make the solution. In order to help you remember those three words, because I think most people get the idea, they just have a hard time keeping track of those three, remember this sentence. I would recommend writing it down in your notebooks. You mix the solute into the solvent to create a solution. You mix the solute into the solvent to create a solution. If you write that down in your notebooks, you have that in your memory, you will always be able to remember which one is the solute, the solvent, and the solution. Really what I think we could use here is a little bit more practice, just using these three terms to make sure that you have them down in your mind the right way. So I have two questions right here, question 1 and question 2. They each have three parts, A, B, and C. You're going to tell me in each of these scenarios where Valerie's making iced tea and Max is making green soap, what is the solute, the solvent, and the solution. So go ahead and pause the video and answer 1, A, B, and C, and 2, A, B, and C in your notebooks now. I am now assuming that you have answered these questions. You're unpausing the video because here are the answers. Hopefully that's some good practice. In this case, Valerie mixes iced tea powder into water in order to create iced tea. In this situation, the water is the solvent, the powder is the solute, and the iced tea is the solution. Over here, Max was putting some green food coloring into a liquid soap in order to make it green soap. In this situation, the green soap that he created at the end was the solution. You always end up with a solution. The green food coloring is the solute. And yes, in case you were thinking, oh, Mr. Manager, I thought a solute always had to be like a solid or a powdery kind of thing. No, you can even have a liquid solute, like green food coloring. And the soap is the solvent. So that's like the bigger substance that the solute is getting mixed into. Alright, hopefully you got all those correct. If not, maybe rewind and practice this one more time and try to get down in your head the right way, which is the solute, the solvent, and the solution. There's one more term I also want to point out here, and that's this other word, solubility, that we heard a few times. Solubility is a property, and you should know what that means because, heck, we've talked about a lot of properties these past few days. Things that are soluble can be dissolved easily. Things that are not soluble don't dissolve very well. So it's a way of describing whether something can or can't dissolve. Is it soluble or is it not soluble? So the example that we heard from Crash Course was that if you try to take some sand and mix it up in water, you find that sand is not very soluble. It just clumps down at the bottom. It doesn't spread out throughout the water. Whereas if you take some sugar and you dissolve that into water, sugar is very soluble. It spreads out evenly, it dissolves into the water. And you can even put like a whole cup of sugar into a glass of water and you'll find that it will still be able to dissolve. Alright, knowing that, we're going to take classwork question 2 on right now. Imagine that you were talking to your little brother or cousin and they asked you what a solution is. How would you explain it to them? Try to explain solutions in your own words. Pause the video and answer classwork question 2 now. Assuming you have now completed that question, we are unpausing and moving forward. And we got our last step for today, which is the independent practice. That's right, no crash course videos for today, none of that. We're just reviewing so we can knock out our quiz tomorrow. Alright, for independent practice today, though, we have 10 questions. So go ahead and number 1 through 10 in your notebook. And these 10 questions are right here. Just so that you are aware, numbers 1 through 4 are about the stuff that we talked about just now, but 5 through 10 are questions that might be vocabulary from earlier in this unit. So 5 through 10 aren't necessarily going to be about conductivity or solutions or any of that. They're going to be about other stuff that we've talked about from the whole unit. 1 through 4 are all about conductivity and solutions. Go ahead and answer these 10 independent practice questions in your notebook now. And we're moving along. I'm assuming that you've now unpaused the video. You've answered your 10 questions because, ladies and gents, here are the answers. Number 1, you mix, and this is the sentence that you're always going to remember, right? You mix the solute into the solvent to create a solution. If you remember that sentence, you are good to go tomorrow. Number 2, if your electricity can travel through an object, the object is conductive. That's what it means to be conductive. It means that electricity and heat can travel through it. Number 3, sand doesn't dissolve very well because it is not soluble. If something is soluble, it can dissolve. If it's not soluble, it can't dissolve. Number 4, if heat doesn't travel through an object, the object is not conductive. That's what it means to be conductive. Number 5, color and texture are 2 examples of properties. I could have used a whole bunch of examples other than color and texture. Things we've talked about like reflectivity, magnetism, boiling points, all that kind of stuff. But those are just 2 examples of properties. Number 6, true or false, a shiny new car is very reflective. Well, if it's shiny, then that more or less means the same thing as reflective. So that is true. Number 7, true or false, a brick wall is very transparent. That is false. I have never been able to see through a brick wall, and I've seen a lot of brick walls in my life. If light can't pass through it, then it is not transparent. Number 8, if you could zoom in super close on matter, you would see that it's all made up of tiny particles. That's one of the earliest things that we learned, and we learned that those particles kind of affect the properties that an object has. Number 9, a chemical change happens when the particles that make up 2 or more substances are rearranged to make a new substance. There's all those signs that we talk about that are associated with chemical changes, but really the most important thing to know is that they're all about making new substances. That's why they're special. And number 10, true or false, we can use properties to figure out what mystery objects are. That is true. That is why scientists like to talk about properties so much. That's how scientists decided that Pluto was a dwarf planet. Alright, go ahead and as always, star the questions you got correct, fix those answers you got wrong, and in today's classwork form, check off the questions that you got correct. And that is all that we got for today, ladies and gents. There will be an exit ticket, and as you know, there is a quiz tomorrow, so be prepared for that. And I also wanted to throw in, talking about Kool-Aid so much made me think of this YouTube video from way back in the day before YouTube was really a thing the way it is now, of this guy named Julian Smith, and he just made a silly little sketch in which he makes hot Kool-Aid for his brother, and it makes me laugh. So I'm going to link that in today's classwork. It's just a funny little cool thing. Alright, knock out those exit tickets. Make sure to comment a good morning or good afternoon to me, and I will talk to you guys soon.